Hello students, last class we completed the electric field due to charged ring in the case of complete ring, and in the case of semicircular ring we completed. Now this class will complete one more application, last one, that is arc of a circle, which makes an angle. Quarter part of a circle be taken. Either you can apply this quarter part to any angle subtended by the arc of a circle also we can apply. So here we taken one of the quarter part of the circle. Further we are deriving the equation for electric field intensity, right? So I taken here one of the arc of a circle. You can see the diagram here, which is charged one, and which may subtend an angle 90 degrees at the center. This is the origin, right? At this point it is making angle 90. Now here, to calculate the electric field intensity due to this one at this center of the circle at this O point, so we need to understand first, it is the charges are distributed on this wire of quarter part of the circle. So it is the quarter part means one part of a circle. So total charge of this wire, if you taken as q, and the length of this one is a part of a circle, the length of this one is a part of a circle, that length is equal to, I can take it as, that is nothing but total length of the circle is 2 pi r. In that, one of the fourth part, that is 1 by 4, that is nothing but we can write as pi r by 2 is the length of that. So here I can write the concepts of what I can write the linear charge density, because it is a wire. So linear charge density is equal to charge occupied per unit length, that is nothing but total charge by length is equal to how much? Pi r by 2. Total circle is 2 pi r, half of the circle is pi r, and in that half is that is we can write as pi r by 2. So if you taken pi r by 2, the 2 will be goes to the denominator. So I can write this one as like this in terms of lambda. Now in this case, what is the charge here? Charge q is equal to, that is nothing but lambda into pi r by 2. This is the total charge on the wire in terms of linear charge density concept. Now first, to calculate the electric field due to this curved part, we have a lot of charges are there, so you can't do it. So same like previous, we are going to choose a elementary portion here. That elementary thickness portion, whatever you've chosen, the thickness of this one is I'm taking as dl, elementary length. Now this elementary length is from the, that means from the origin. If you see this one, this is the way the elementary length portion will be. This end will be, this is, and another end will be like this. This is the way the line of charge from the center will be distributed. Now this is this particular angular separation is there. This angular separation we are calling as d theta. Now if you say, now this is the part of a circle, right? Curvature is a part of a circle. So the length of this line I can take it as radius of the circle, like r. So this curvature, whatever you chosen here, this curvature, the curvature is length is equal to, we taken as a length dl. This length dl we can write in terms of r d theta, according to the theta is equal to arc by radius. So theta is equal to arc by radius, arc is equal to theta into radius. So r into, what is the theta here? D theta. Now our requirement is, this is positive. Now what is the direction of the electric field due to that elementary portion? For that, already we discussed in the previous, you have to imagine a test charge at this point so that you can identify the direction of the electric field. So this positive and repel this positive, in which direction? This is the way the repulsion is going to take place. So this is the direction of the electric field due to that elementary portion, I can say. This electric field due to a small portion I am writing as dE. Now this dE, how much angle it is making? It is making certain angle. So resolve this dE into components, according to that. If you say, if you are taking an angle from the x-axis, if it is making an angle theta, now this theta according to that I can take it as this is also theta. So resolve into components. dE, if you resolve into components, you are going to get dx component, one component. Second one is dy component, I can write as. So in this case, what is the dx and dy components if we come across? So here the charges are distributed from which angle? Theta value minimum is 0, and maximum is how much? That is nothing but pi by 2. So in this case, to calculate the electric field intensity along x-axis, you take the component that d is equal to nothing but, that is nothing but dx component plus dy component. This is the way you have to take first. So what is the electric field along x-axis? If you want to come across electric field along x-axis, if you want to come, so dE, if you resolve into components, this dE if you resolve into components along theta side, you get dE cos theta. and dEy, if you resolve into component, you will get dE sine theta. This is important for us. dE cos theta, dE sine theta. So to calculate the dx equal to what I can write, that is nothing but dE cos theta. Now we have to integrate this one both sides. So integral dx equal to ex, and this is integral dE is equal to nothing but electric field intensity at that point, that is 1 by 4 pi epsilon naught due to this elementary charge dq at the origin at a distance of radius, that is r square, into cos theta. But dq value is not given, but dq value we can write it from using this equation. What I can write the equation? So already we have a, okay, one of the concept we got, the charge q is equal to lambda into pi r by 2 we got. So similarly, dq is equal to what I can write? dq is equal to lambda into length of that one. What is the length of that one? That is equal to d. You take it like this. So this length is equal to, we have to integrate now. So this length also we can write in terms of dq is equal to lambda into dl. I can write as r into d theta. We can substitute this dq value in the above equation. We are going to get ex equal to nothing but, that is 1 by 4 pi epsilon naught is constant, no integration here, take it outside, and r is the radius, that is also, we have a constant, you take it outside, r square, and remaining is integral dq. What is dq? That is lambda into r. In this, lambda is also a constant, you take it outside, and r is also constant, take it outside, remaining is, we have a cos theta into d theta. But we have to integrate from where to where? From minimum angle 0 to maximum angle pi by 2, you have to integrate. So this is 0 to pi by 2 is the limits you have to apply. So if you calculate this one, what you are going to get? Electric field along x-axis equal to, that is lambda r by 4 pi epsilon naught into r square into integral cos theta is equal to nothing but sine theta. Lower limit is 0, upper limit is pi by 2. If you apply this one, anyways, okay, if you apply this, what is sine 90? Sine 90 is equal to 1, sine 0 is equal to 0. So according to that one, I can write as lambda r by, this is 4 pi epsilon naught into r square into, this becomes, okay, sine 91. So anyway, you get 1. So sine 0 is 0. So in this case, 1 r here I can cancel. So after cancellation, what I can get? Lambda by, that is 4 pi epsilon naught r here. So this is the electric field intensity due to this arc at the origin, at the center of the arc, okay, due to x component. So similarly, we have to calculate for y component also. That y component is, which is the reason? This is the reason. Now we are going to calculate the y component electric field due to that. Now what is electric field due to y component? That is nothing but dEy. dEy is equal to nothing but dE sine theta. According to previous diagram, you can check it once back. So now we have to integrate this one the same way. Okay, so integral dy is equal to Ey, we can write, that is equal to integral, this is 1 by 4 pi epsilon naught into charge dq by distance is radius of the one, r square into sine theta. Now here also replace with the dq with terms what we done just before. 1 by 4 pi epsilon naught is constant, and here dq can be replaced with what term? Lambda into r into d theta we can replace, where lambda r is constant, I taken as outside lambda r, and the denominator we have a r square, that is also constant, you take it as r square. Now integral, this becomes sine theta into d theta. So lower limit is 0, upper limit is, that is pi by 2 if you take it. So if you integrate this one, what you are going to get? Ey is equal to, that is nothing but lambda r by 4 pi epsilon naught r square into integral sine theta is equal to minus cos theta, you are going to get minus cos theta, and 0 to pi by 2. So anyway, cos 0 is equal to 1, cos 90 is, anyway, that is equal to, okay, cos 90 is equal to 0. So in this case, what I can write? Okay, minus of minus becomes plus, that means Ey value is equal to nothing but E by 4 pi epsilon naught r here. So both the values, so what is totally electric field at that point is equal to electric component, that is dE is equal to, that is dEx value plus dEy value, already we calculate after integration. So electric field is equal to x component. What is x component? x component is equal to lambda by 4 pi epsilon naught r you got plus and lambda by that is 4 pi epsilon naught r you got. This is I component. If you say this is j component, so electric field due to this quarter part of the circle, that is which subtend an angle 90 degrees at the center of the circle, is equal to lambda by 4 pi epsilon naught r I cap plus lambda by 4 pi epsilon naught r j cap. This is the most important formula you have to keep in mind. This is over about the discussion of electric field due to charged ring, of complete ring, of semicircle and quarter part of the circle. Suppose if the question is given for any angle, that means if the arc is making certain angle. So example, if you say just okay, if any part of an arc is given, this is the one of the arc which is given, this is arc, we don't know the angle subtended by this one. What you have to do is you have to take the angle subtended by this one at the center. How much angle it is subtending at the center, you take that angle is equal to, take it as this is theta, you don't know that. In this case also same like previous, just you have to go like take the coordinate system here, this is x-axis you can take, and you can take the y-axis here. By taking the x-axis and y-axis, choose the elementary portion, same like previous elementary portion. Due to this elementary portion, the direction of the electric field, you have to indicate the direction of the electric field at this point. You can indicate the electric field direction in this case like this. So here also it's the same thing. So this electric field is dE, which is making an angle theta with respect to that one. If you take, this is the theta some value, okay, theta dash, if you say that is also theta dash, I can say resolve into components, you will get dE cos theta dash, one component. Second component is the dE sin theta dash. So this is x component. If you say this y component, similarly if you solve it, you'll get the same relation wise, but we are not substituting any limits here. So whenever the limits are not substituted, in that case Ex value is equal to how much you are going to get in terms of equation you get, that is without limits, that is nothing but lambda r by 4 pi epsilon naught r. Anyway, after cancellation directly I'm writing here r we are cancelling, lambda by 4 pi epsilon naught r into, we are going to get the first equation as cos theta. Cos theta, in this case the theta value is what theta limits you are applying, the component here. Similarly y component, what you are going to get y component, that is also lambda by 4 pi epsilon naught r, but in the place of this one we are going to get minus cos theta. Sorry, previous one is not cos theta, this is sin theta you are going to get. This is the sin theta component you are going to get, and this one is minus cos theta component you are going to get. So this is y component, so I can write as j cap. This is x component, so I can write this one as I cap. So I can write the total equation, electric field intensity is equal to lambda by 4 pi epsilon naught r. If you take in common in this case, I can write as sin theta I cap minus cos theta j cap. This is the electric field intensity due to a curved wire which is subtending any angle at the center. Now you can apply this formula to solve it for calculation of electrical intensity due to a curved part of a charged ring, okay, or charged arc. That's it. Now this concept is related to disk. Now we are finding the electric field due to a charged disk. So it is a little bit mathematical approach will be there, so it takes little time for explanation. Try to understand the concept for the derivation of this electric field due to this charged disk. Disk means which contains surface area, that means where the charges are distributed across the area. So this is the one of the disk I taken. Whenever the charges are given to this one, these charges will be accumulated throughout the area of the plate, that is the disk. Now due to this charged disk, we are finding the electric field intensity at a point along the line taken from the center of the disk, that is along the axis of the disk we can say, which is a distance of x. Now the disk which you taken having certain radius, the radius of the disk is I taken as r. R is the radius of the disk. R is the radius of the disk. Now, so to find the electric field intensity at this point, first you need to understand the concept here. The total charge of the disk is q. where the charges are distributed across the area. So there is a distribution of charge in terms of area, that is called as areal charge distribution, that is equal to sigma is equal to charge occupied per unit area, that is q by pi r square, because area of the disk is equal to pi r square. So from this I can write the charge on this disk is equal to sigma into, I can write as pi r square, where r is the radius of the disk. Now after getting the charge on the disk, now choose the elementary portion at anywhere. I chosen this elementary portion here. The elementary portion length is, you take it as dl. Okay, the elementary portion length, sorry, it is not the ring, it is a disk. So we should not take the concept of which one, elementary portion. Here, to calculate the electric field intensity due to this disk, what you have to do is you have to imagine one of the, okay, you have to imagine one of the ring, small ring area you have to imagine inside. This is the place I am taking here. I am taking a small ring area which contains the inner and outer, which contains certain thickness. I taken one of the ring, okay, small portion of ring I chosen here. This small portion of ring which having certain thickness, this is the ring I chosen here. The disk is I taken into number of small rings I can cut. So I chosen one of the ring here. The ring is having, okay, certain thickness. The thickness of the ring I am taking as dr. The radius of this ring I taken as small r. The radius of the ring is I taken as small r, right? Now what we are doing is we are calculating the electric field intensity due to this small charge ring. This dr contains the charge, that is dq, because inside this ring the ring contains the charges. So there is a, okay, charge, that charge is very small charge dq across the thickness of the dr. Now due to this charged ring we have electric field intensity at this point p. Now what direction the electric field intensity, from the previous classes you have to understand the direction of that electric field intensity. For that you have to imagine a test charge here. If you imagine a test charge here, the charge on this ring, whatever you taken, that will be repulses this, okay, the charge on this ring will be repulses this charge in this direction. This is the direction of the repulsion of that electric field. So this electric field is nothing but dE we can write. Again, if you take in the coordinate system here to calculate the direction of that one, you take the coordinate system, that is x-axis I chosen. Okay, you choose the x-axis, choose the x-axis, and also y-axis you choose it. This is x-axis and this is y-axis. This is x-axis, this is y-axis. Choose the coordinate system. Now how much angle it is making? It is making an angle theta here. So dE resolve into components. What you are going to get, that is nothing but dE cos theta, one component you will get. Second component is dE sin theta, you are going to get another component. So anyway, in the case of same like ring, so in the case of ring, what is dE? Okay, y component, the dE y component will become equal to 0, because due to lower part electric field, upper part electric field, vertical components will be get cancelled. So dE sin theta will be get cancelled here due to opposite portion of the ring. But there is a dE cos theta, so we have electric field due to this small elementary portion ring at this point, that is dE cos theta. So electric field due to that small ring which you imagine is equal to dx equal to nothing but I can write as dE cos theta. Now we need to calculate for this dx value. Now this one you have to integrate both the sides. So integral dx equal to dx I can write. Now what is dE? dE nothing but electric field. That electric field I can write as 1 by 4 pi epsilon naught into charge. How much charge? That is dq by distance. What is the distance of the charge? From here to here. This is the distance of the charge. So now that distance I am taking as y. That distance I am taking as y. If you take that one as y, I can write as y square into cos theta. Now what is cos theta from this triangle? If you see this one, this is the theta. If you say from the triangle, cos theta is equal to adjacent by hypotenuse, that is nothing but x by y. This cos theta from this triangle, from the triangle, I can write as x by y. You can replace. If you replace that, what you are going to get, that is Ex equal to integral 1 by 4 pi epsilon naught into dq by, that is nothing but y cube we are going to get into x. This is the one of the equation part. In this case, what is y value? Y value is equal to, from the diagram, I can write the y value is equal to, using Pythagoras theorem, I can write y value is equal to nothing but, so small r square plus x square, I can write small r square plus x square, where x is the position of the point, r is the radius of that elementary portion which you choose, right? So this is the way. Now what is dq here? That is important for us. What is dq? Elementary charge. How much charge will be present on that elementary portion? Total disk charge is equal to how much? Q is equal to sigma into pi r square. But elementary charge is equal to dq is equal to, that is sigma into that area. That means this ring not having area, it is having circumference as well. This is having, okay, length of the circle as well as thickness. So the area of that ring I can take it as in terms of circumference of the ring. What is circumference of the ring? That is 2 pi r, because r is the radius of that ring. R is the radius of this ring. That's why I taken 2 pi r into thickness of this. What is the thickness of that one? Dr. That is nothing but area. So dq is equal to sigma into area. That area is, we are writing in terms of circumference of that ring into thickness of that. That gives area 2 pi r into dr. Now this one you can substitute in the equation. So we'll get the one of the equation Ex equal to, that is integral 1 by 4 pi epsilon naught into dq value is equal to sigma, that is 2 pi r into dr, by, what is y value? Y value is equal to nothing but r square plus x square whole cube, because we have a cube is there, whole cube into x. This is the equation we got. Now this equation you have to integrate, and you will get the result required for the electrical intensity. Now this equation integration, where to where you have to do? The inner ring, if you taken minimum radius 0, maximum radius is r. So we have to integrate the limits up to 0 to r. Before that, this is the complicated okay, differentiation. That's why to solve this one, this is 2 pi, 4 pi, I can cancel 2 times. Remaining terms you can write it, which are the variables. Ex equal to, what are the variables here? Sigma is constant, not a variable, take it outside. And x is constant, distance of the point, that is also constant, take it outside, x by, okay. Next what we have, 2 is constant, take it outside, epsilon naught, take it outside. Now remaining is integral 0 to r, and here we have a r into dr by r square plus x square whole power 3 by 2. We have to integrate this. To get the integration, this one, for simple method, what we can take is, here r square plus x square, r square plus x square is equal to, I am taking as t, I am considering as t. Now okay, write the okay t in the form of, if you differentiate the t in terms of differentiation, dt is equal to, I can write as 2r, r square differentiation 2r into dr, I can write, x is constant, no differentiation. So from this I can write the okay r dr value. What is r dr value? R dr is equal to nothing but dt by 2, one value, I can use it in the expression. And that expression, if you apply here, what is r dr? I can replace with the dt by 2. Now what is r square plus x square? I can replace with a t. If you replace here, this differential integration function will becomes like this, sigma x by 2 epsilon naught, that is integral 0 to r. Now I can write that is nothing but dt by 2 into dt by 2 into, this is nothing but t you are going to get, okay, r square plus x square, t power 3 by 2. Now this is the equation you are going to get. Now if you 2 take it outside, that becomes 4, that is ex equal to, that is sigma x by 4 epsilon naught, I can write. And after that this is integral. So this is in the form of what? T power 3 by 2. If you make it upwards, t power minus 3 by 2 you'll get. So that means I can write that one in terms of integral, okay, that is t power minus 3 by 2 dt value separately I will do here is equal to nothing but, it is in the form of x power n dx formula, that is t power minus 3 by 2 plus 1 by minus 3 by 2 plus 1 is answer. So that means this value is equal to how much you are going to get? Minus 3 by 2 plus 1 is minus 1 by 2 you get. So that means after integration, this one I can write as a denominator value. Okay, denominator value is equal to minus, that minus I am bringing front, okay, minus 1 by 2 I can write here. that is minus 1 by 2, and t power minus 3 by 2 plus 1, this is also becomes minus 1 by 2. T power minus 1 by 2, if you bring it down, it becomes t power plus 1 by 2. That t power plus 1 by 2 I am writing as root t. So root 2 is nothing but, power is nothing but 1 by 2. So t power 1 by 2 I can write as root t. So this is after doing integration method you get. The limits of this one is, the lower limit is 0, upper limit is r. Now I can cancel here 2, 2. After taking outside, you get this. So Ex equal to what I can write, that is nothing but minus, take it inside, sigma x by 2 epsilon naught. X is also, if you want to take, you can take it inside. Because inside we have x term. So I can write as 2 epsilon naught. I am taking minus x inside. That is minus x by root t. You are going to get 0 to r is the limit of that. Now what is t? T is nothing but what we consider t, we consider as r square plus x square. Now you can replace here. Now if you replace the t value, that is nothing but Ex equal to sigma by 2 epsilon naught into, that is nothing but minus x by, that is under root of r square plus x square, r square plus x square, sorry, small r square, that is not capital R square. So small r square plus x square, we can write 0 to r. Now again, if you write this one, again if you write this one, what form I can write? I can write in this form of this one. This is Ex equal to, this Ex equal to sigma by 2 epsilon naught, upper limit minus lower limit. So put the x is anyway constant. What is variable r? R is changes from center to outside. Center is 0, radius, edges is r is a radius. So I can replace this, small r is equal to capital R, I can replace. So first term minus x by under root of, I can write as capital R square plus x square, I can write. Next minus, already we have a minus, minus of minus become plus, that is plus x by, okay. So put the r value is equal to 0. If you put the r value 0, you are getting under root of x square. Under root of x square means you will get x value. So in this case, I can cancel this, okay, x, that means you will get 1, and the remaining term you can write as, okay, in an order. If you write in an order, what you are going to get, Ex equal to nothing but is equal to sigma by 2 epsilon naught into, that is x by x is 1, that 1 I am taking in front, 1 minus, remaining term I am writing as x by, that is under root of r square plus x square. So this is the one of the expression, electric field intensity due to this charged ring of charged disk along x-axis. Anyway, along y-axis is 0, so this is the expression of this one. So here you need to understand that, okay, if radius of the ring, r is the radius of the ring, right? So compared to the distance of the point, radius of the ring is, if it is very small, then we can neglect the radius of that one. If you put the value of r equal to 0, what you are going to get? R equal to 0. If r is less than r is less than x, if you say, in that case, Ex value is equal to how much you are going to get? Sigma by 2 epsilon naught. It becomes like a single charge, 1 minus, so x by x you'll get. Yes or no? R value is okay. If you take it as 0, root x square equal to x, x by x is 1, 1 minus 1 is 0. So electric field intensity will become 0, right? Suppose if the radius of the disk is very big means if r is greater than x compared to distance of the point, if the radius is very big, in that case, the effective radius is more than x value. In that case, put the x value 0. If you put the x value 0, Ex equal to how much you are going to get? Sigma by 2 epsilon naught into, that is 1 minus, okay, that what I can write, that x value, if you are putting r value is equal to, okay, x value if you are putting 0, this value will becomes equal to 0. So 1 into 0, how much you are going to get? That is nothing but Ex equal to sigma by 2 epsilon naught you are going to get. Second term anyway becomes 0. So there is electric field we are getting still if the radius of the disk is very big compared to distance of the point. That means if you take an infinite okay, area of charged disk, in that case electric field will be exist along the axis, that is nothing but sigma by 2 epsilon naught. That means in this case, it is independent of the distance of the point. So if you take a small, okay, one or big one, okay, if it is infinite one, in that case, sigma by 2 epsilon naught is okay point. It is independent of the position. That means whatever may be the position, the electric field intensity will be remains same in the case of infinite charge point. So sigma by 2 epsilon naught. This concept is most important in the case of charged sheet. Also, we are going to discuss in the coming topic. So the final conclusion is electric field due to a charged disk at any point at a distance of x is this is the formula. Now, if the radius of the disk is very big one, that means if the charges are infinite charges are present, in that cases electric field is independent of distance. There is no x value, no x is present here. There is independent of x value. So independent of x value means whatever may be the okay size of the charged body. If the charges are infinite, it is independent of the position of that. Everywhere the electric lines will be okay present. It is independent of that. That means uniform electric field will be there across the charged disk. I can see this is the end of this which one disk. Now just before we completed one of the disk concept, we got the concept that if it is the disk, the aerial charge distribution takes place, the charges are distributed aerially. In that case, the electric field intensity due to that infinite charge distribution is independent of the distance. So here, using the concept, we are finding one relations here in a particular regions. I taken 3 sheets here. They are okay, infinitely charged sheets are taken here. So in this infinite charge sheets, 3 are taken here, and they are separated by certain distances. Here we are not bothering about the distance because the infinite charge sheet is independent of the distance. So we taken 3, and we have certain regions are found here: first region, second, third, fourth region. And these plates are given charges. All are given positive charges here. That means positively charged, infinitely positively charged plates is taken here. Now we are finding the what is the electric field intensity at first region, second region, third region, fourth region. That we are finding. So anyway, the common formula for electric field intensity due to infinitely charged okay disk, that is nothing but sigma by 2 epsilon naught. In the case of sheet also, if it is infinite okay charged sheet, that is also sigma by 2 epsilon naught, because it is aerial charge distribution. According to aerial charge distribution derivation we done in the previous, and it is independent of position, so it is only depends on charge density, that is by 2 epsilon naught. So 2 is constant, epsilon naught is anyway constant, sigma is called charge density based on charge density depends. Now here I taken all are okay having same charge densities, all are having same charge densities. If you want to write different charge densities, I can choose as okay rho 1, this is rho 2 and rho 3. Like that also we can take different charge density, will take better. So if you take on the different charge densities rho 1, rho 2, rho 3. Now what is the electric field intensity in the first region? This is the first region. I say what is the electric field intensity in the first region? Now we will calculate. To calculate the electric field intensity at the first region, so first here this is the plate which is having positive. So imagine a test charge at that point, so that to understand the direction of the electric field. Anyway, this positively charged plate okay creates the electric field at this point in this direction. Yes or no? In the direction of the charge, that is towards the left hand side, that electric field will be created. So this is the direction of the electric field, that is due to first charge density, that is rho 1. That I am writing as E1. Next, if we come across the case of second one, this positive also repel this test charge okay in the same direction. So that means I can take it that arrow mark also in the same direction. Now third one I am taking as this is the second one, and okay third one I am indicating with the blue, and in this case the third one also repel, the positive repel this one, and that also in the same direction because it is independent of distance. So 3 positive plates will be repelled that test charge Q0 in the same direction. 3 are in the same direction as they are looking like this. So I can write the equation of that at that first region. Electric field intensity in the first region is equal to, that is due to electric field intensity due to first one plus second one plus third one. So if you are taking as electric field along x-axis is positive 1, along negative axis is negative 1 if you taken, that we can write as okay all are addition along with the minus sign, you can take it along with minus sign. Why we are taking minus sign? This electric field at region 1 is acting towards the negative x-axis, so minus. So what is the expression for this one? I can write as minus if we take in common. What is even formula? That is sigma 1 by 2 epsilon naught, sigma 1 by 2 epsilon naught, plus second one also sigma 2 by 2 epsilon naught, third one also sigma 3 by 2 epsilon naught. This is the equation you are going to get for the case of this electrical intensity in the first region. Similarly, in the second region, if you come across a case of second region, what is the electric field intensity? Imagine a test charge here. In this case, the first plate, the positive plate repels this charge. What direction? The charge, it is repulsed in this direction. It is going to repulse in this direction, right? So this is the direction of the repulsion, I can say, by the first charge. That I can take it as C1. What is the, okay, for what is the direction of the electric field due to second charge? The second sheet having positive, that positive repel this one in this direction. The second one is going to repel this one in this direction. That is, I can take it as E2. Right? This is a charge Q0. Now third plate. Third plate is positive. The positive repel this one positive. In which direction? This is the direction of this one. So that is nothing but E3. So E1 is right side direction. E2, E3 is left side direction. So I can write the net, okay, that means net electric field in the second region is equal to nothing but I can write as, okay, positive direction and my negative direction. So I can write in this case E1 minus remaining is E2 plus E3. Both are opposite. E2 plus E3 by, okay, sorry, no by, this is only our requirement. This is E1 plus E2 so E1 plus E2 plus E3, because E2 plus E3 both are combined, E1 is opposite, so E1 minus E2 plus E3. Now if you want to write in the form of charge density, E2 is equal to second region electric field is equal to sigma 1 by 2 epsilon naught minus, that is sigma 2, okay, plus sigma 3 by 2 epsilon naught by taking common. Similarly, what is the electric field in the third region? If you come across the case of third region, so the electric field intensity in the third region due to first plate repels the charge in this direction, and second plate also repulses charge in the same direction. Yes or no? Second plate also repels the charge in the same direction, both are the same. But third one is repulses the charge in this direction. So both are, in this case, E1, E2 are in the right side direction and E3 is opposite direction. So take the electric field in the third region. The electric field intensity in the third region is equal to what I can write? That is nothing but E1 plus E2 minus E3 we can write. So in terms of charge density, I can write as electric field in the third region. Okay, electric field in the third region is equal to, that is sigma 1 by 2 epsilon naught. That means sigma 1 plus sigma 2 by 2 epsilon naught minus sigma 3 by 2 epsilon. So this is a way I can write the expression of this electric field in the third region, electric field in the second region, and electric field in the first region. And if you come across the case of last one, what is the last one? Fourth region. So what is the electric field in the fourth region? If you come across the electric field in the fourth region, three plates are left side. The three plates will be repulse the charge in this direction. First one, okay, and the second one, and third one. Three will be in the same direction. Three will be in the same direction means that is nothing but we can say as E1, E2, E3. So total net electric field in the third, okay, region, fourth region, not third region, it is a fourth region. Fourth region is equal to nothing but we can write as E1 plus E2 plus E3 at 3. So I can write this one as, so all are same, sigma 1 plus sigma 2 plus sigma 3 by 2 epsilon naught. This is the electric field intensity in the fourth region. Like this we must use. Suppose if the charge density is negative, you have to use the negative. If the charge density is positive, you have to use the positive. If the electric field is towards the left side, you have to use negative. If the electric field is towards the right side, you have to use positive. If you use the sign convention of this one, like this, two combination of charge sheet, three combination of charge sheet, electric field between the charge sheets, they will last the, okay, some competitive exams questions will be asked and distribution of the charge will be asked. And one more last point here we can discuss in this case, most important. Suppose this is the sheet having, okay, thickness. Suppose if you taken the certain thickness of this one, the sheet is conducting sheet. If it is conducting sheet, in that case, inside the conducting sheet, electric field is equal to 0. Inside the conducting sheet, electric field is equal to 0. If it is not a conducting sheet, then electric field inside will not be 0. There will be electric field will be present. So in the case of conductors, what is the electric field inside the charge sheet? That will be always 0, because you know that neutral charges will be exist inside, and outside only the charges will be present. That charges will contribute the electric field in this. So here it is we taken, okay, one more concept is a thin sheet, thick sheet. We will discuss later. This is only basing on the concept of aerial charge distribution, how to calculate the electrical intensity at different regions. Now this concept is related to two opposite charge sheets. Means I given charge on this one. One is positively charged density, aerial charge density sheet, and the second one is negatively charged sheet. I think both are uniformly charged one only. We are discussing on this. Now we have three regions are present here. This is called region 1, this is called region 2, this is called region 3. Now we are finding the electric field intensity at region 1, 2, 3. We are finding the electric field intensity at region 1, 2, 3. So what is the electric field intensity at region 1, 2, 3? If you find it, that's our completion of this concept of sheet. Okay, first come to the case of outside, first region. If we come across the case of first region, the first sheet is positively charged 1. So imagine it is charge. So that what happens is positive repels. What direction it is going to repels? You know that this is the direction of the repulsion. This repulsion indicates the electric field intensity due to that positive E plus. Next, negative. Second plate is negatively charged 1. So negative always attracts the test charge positive. Okay, always attracts the test charge positive. What direction? Towards it. So there is a direction of the electric field due to that one in this direction. So this electric field is we can write as E minus. So here it is independent of distance of that point. Electric field due to charged sheet is independent of distance. That's why what happens, electric field intensity both are similar magnitude but only opposite nature. So I can write electric field intensity in this first region is equal to 1 is, okay, that is negative, okay, that is nothing but E plus, and minus E minus. Both are opposite direction. So what is E plus? That is sigma by 2 epsilon naught, minus second one also sigma by 2 epsilon naught. So if you take sigma by 2 epsilon naught, what you are going to get the result here? In this case, it is going to get electric field intensity in this region due to this one is equal to 0. You will get at that point. Next, if you come across the case of second region, this is the second region in between. In between second region, if you see positive, repel this test charge in this direction, negative, okay, attracts the, okay, that test charge in this direction. Both will be in the same direction. Yes or no? Both will be in the same direction. That means E1 and E2 both will be in the same direction. So first one, and that is plus charge and minus charge, both will be in the same direction. So both will be in the same direction means what is the electric field intensity in the second region? That is equal to nothing but E plus plus E minus here. If you taken that one, that is sigma by 2 epsilon naught plus sigma by 2 epsilon naught, you will get that is equal to, if you taken this one 2 times of whatever you are getting, 2 by 2 epsilon naught, you will get 2 to get cancelled, that is equal to how much you get, sigma by epsilon naught. So what is the electric field intensity in the second region? The electric field intensity in the second region is equal to sigma by epsilon naught. So there is a electric field intensity present in between. Now what is the third side? This is third. If you come across the case of third region in this case, this is test charge Q naught that is attracted by negative. So there is a electric field intensity due to negative charge in this direction. Positive repulse, there is a repulsion here. So This is the direction of the repulsion due to positive charge, that is E plus. So both are always opposite direction. In this case, opposite direction we can say. So according to that one, what I can write here, electric field in the third region is equal to nothing but both are opposite directions. Simply we can minus it. That is nothing but if you write E plus minus E minus, okay, that is equal to both are same charge density, that becomes equal to 0. So what is the electric field intensity at first region 0, third region 0, but what is the electric field intensity at the middle? That is sigma by 2 epsilon. That means there is electric field exists between the two opposite, okay, sheets present. That is nothing but sigma by epsilon. So this concept is involved in the next coming topics, that is in the capacitors concept in that. So this is the most important concept to remember. How to find the electric field intensity at different regions according to the charge densities. Positive negative field taken, electric field intensity at the in between the two opposite charge, okay, sheets is equal to sigma by epsilon naught. That is important for us to remember. So in the next class we are going to discuss regarding the spherical charged bodies, and how the charges are distributed on the spherical charged bodies, and what way electric field intensities are depends on the spherical charged bodies in the case of conducting spherical body, non-conducting spherical body, halo conducting, and solid conducting. Like that we have classification, and along with the graphs are there, we will discuss in the next class.